Okay, so till previous week we have discussed what are differential equations, what are types of differential equations, what is the order of a differential equation, what is the degree, what is the solution, general solution or particular solution. And after that we did not go into the solution of different types of differential equations, but we discussed, okay, when does the solution of differential equation exist and when is the solution unique. Like we discussed the Lindelof theorem regarding that. And after that we move towards direction fields, that how can we approximate the solutions of differential equations with the help of direction fields, also called slope fields. And the quick way to do it was, I think, isoclines and nullclines, and there were some other terminologies as well. So from today onwards we are going to discuss the traditional things that we need to discuss, but these things are very much important regarding the exam point of view. Like we start from separable equation. What we should know that what is the general form of separable equation. Yes. Then how to solve it. Mostly in most of the exams you are not asked to solve. You are asked to solve in some of the examination, I think in FPSC, Federal Public Service Commission. They give a differential equation and they ask you the solution, which I have seen 1 or 2 times. But in other exams, they never ask you about the solution. They ask you, okay, if you have homogeneous equation, you can convert into separable, then you use what type of transformation. Then you should know the transformation only that you use. And if a differential equation is exact, what is the condition that it must satisfy? So you have to remember only these points, nothing else. But at least for some other exam point of view, you should remember how to solve those equations. So our discussion begins from very elementary differential equations. In the first discussion, we are discussing first order differential equations. So the first thing is separable ordinary differential equations. So these are equations of this form: f of x dx plus d of y dy equals 0. So you can manipulate this form in so many other forms as well. Like you can take this form on this side and you can say that, okay, if you are given this type of differential equation, f of x dx is equal to g of y dy, this is also separable. Because how can you write it? You have a function of x explicitly multiplied by its differential, and you have a function of y explicitly multiplied by its differential. I have written a capital G and capital F because this and this has no relation with each other. These are just examples. So whenever you have differential equation in this form, you can call it is separable. Or whenever you are going to write it, or you are able to write it into this form, after some simplification, you call it separable differential equation. And how to solve this? The method is very simple, just integrate. Nothing else. So we are taking some examples. Maybe the examples will not be clear enough, but we have to manipulate it a little bit, then we are getting the right way to solve. So let me write one of them. Example: x e raised x square plus y and dx equals y dy. So seemingly we can see that it does not look like a separable differential equation, but we can separate the variables. The problem is this y.
Yes, sir.
But we can write this e raised to x squared times e raised y dx equals y dy. And we can take this thing over here, then this becomes x e raised x squared dx equals y e power minus y dy. Now you can see this is explicitly a function of x multiplied by dx. This is a function of y multiplied by dy. Then you just integrate and you get your result. This is x e raised to the x square dx equals integral y e raised to minus y dy. About this integration, this is very simple.
e power x square upon 2.
Yes.
Upon 2.
Just you have to exist this derivative,
Yes,
which is
sir.
2x,
2x.
multiplying and dividing 2. Then our answer is e raised to x square. And here we have to apply integration by parts. Y times e raised minus y dy.
Yes, sir.
And u same integral of y
Minus y power minus y.
minus derivation of u integral of e, that becomes plus.
Plus.
But when you integrate, that again becomes minus. So this is your answer. And you introduce a constant of integration, which is
Yes, sir.
so you just apply integration by parts. You are up to here. And we call this solution to be implicit solution, because this solution is in this form: f of x comma y equals 0 when you take these all the things on one side, or f of x comma y equals some constant, whatever you call it. Whenever you are going to separate these things, like you write y is equal to f of x, we call this solution to be explicit solution, but we call this type of solution or this solution to be implicit solution. Sometimes we are interested in explicit solution, but sometimes we are unable to get explicit solution. So this is implicit solution. I think we will not be able to simplify this, but there might be some ways, but right now we are unable to do it. So a separable equation has this form. You are supposed to just separate the variables and integrate, nothing else. Okay.
Explicit system, we will use chain rule or something like this in implicit function.
In explicit,
Yeah.
we apply chain rule for differentiation. Yes. We apply chain rule whenever we have some composite functions like y is equal to f of gx, f of g of x. We apply chain rule to differentiate. Yes. Okay. So next thing is, what do we mean by homogeneous equations? So second thing is homogeneous equations. There are different homogeneous equations. This one are in the case of first order differential equations. We have homogeneous equations in the higher order differential equations as well, and we have homogeneous system of equations in linear algebra as well. So to discuss homogeneous equations, the first thing we should know is what is a homogeneous function. So I am given a function, let's say f of x comma y equals 0, or let me write it as z is equal to f of x comma y. I have this function which is function of two variables x and y. If the degree of every term is same, and let's say the degree is n, we call that function to be homogeneous function of degree n. For example, there is a mathematical description for that. You have this thing x square plus xy plus y square. The degree of this term is 2, the degree of this term is 2, and the degree of this term is 2. Then we call this is homogeneous function of degree 2. But for example, I have here x square y, then this degree becomes 3, then we don't call this homogeneous function anymore. Okay, so you have degree of each and every term to be same. What is the degree of a constant? 0 always. And the degree of a linear term is 1, the degree of quadratic term is 2, and so on.
So there is again ambiguity between 0.
Yes.
So many people saying that 0 have a 0 degree, some will say 0 is not defined as a degree, 0 degree. 0 has no particular degree, I mean to say.
If we talk in the sense of polynomials, we can call it a polynomial of degree 0. Because in the sense of polynomials, we say we have a polynomial. What is the degree? 1. And if we have a polynomial in a constant form, we call its degree is 0. In the sense of polynomials. But if you go in the sense of linear algebra, we have a 0 vector its basis contains only one vector, that is 0, and the number of vectors in your basis is called the dimension of the vector space, and so on. So you have that vector space with dimension 1. But it does not make sense, but it has dimension 1. Because when you go in linear algebra, you have a point, we call dimension 0. You have R1, we call dimension 1. You have, let's say, R2, we call dimension 2. You have R3, we call dimension 3. But this 0 vector is also dimension 1. This is some sort of ambiguity in that. But this has nothing to do with different aspects of dealing with the same object. You are dealing with polynomials right now, so deal it in the same way as we are doing so. So, we call this function to be a homogeneous function of degree 2. What is the mathematical description? A function is called homogeneous if you replace x by some sort of tx and replace y by ty, and you get the same result f of x comma y, just multiplied by t raised to power n. Then we call this to be the degree of this particular function, and if this condition is satisfied, we call this function to be homogeneous function. So this is what we call homogeneous function. So you can check the things in this case. What is f of x comma y? X square plus xy plus y square. F of tx and ty becomes tx becomes t square x square plus tx ty becomes
t square x
t square xy t square y square. Just take t square common, x square plus x square plus y square. Then you have t square and f of x comma y. So you can see that this number n is 2. So this is a homogeneous function of degree 2. So if you are done with the homogeneous function, then we can define what a homogeneous differential equation is. So we should at least know this thing. If don't, then we should at least understand how to check that whether each and every term has the same degree or not. Okay, so you have a differential equation, let's say m of x comma y dx plus n of x comma y dy equals 0. This is called homogeneous equation if m and n are homogeneous functions of same degree. So, okay with this, you have a differential equation in this form. It is called homogeneous if the function m and n are homogeneous functions, but their degree must be same. We can rewrite this equation into this form as well. Dy by dx equals f of x comma y divided by g of x comma y. We can rewrite in this form as well. Then we can call that if f and g are homogeneous functions of same degree, then we call this to be the homogeneous equation. Okay, how to solve it? You just write your dependent variable as independent variable times some other parameter v. Then this transformation helps you to reduce to convert this equation into separable equations. This is the idea behind solving it. So you just substitute y is equal to vx. After this substitution, this leads you to a separable differential equation. So you are supposed to keep these big things in your mind. Then you also find y prime, that becomes v plus x dv by dx. I think it's okay. The derivative of x is 1, v same, and x is same, the derivative of v is dv by dx. So you just do these two substitutions, you are done with converting your differential equation into separable form. So let us see one example, that is dy by dx x cube plus y cube divided by x square y plus xy square. We can see that the numerator is each and every term with degree 3, degree 3, degree 3. So this is homogeneous function of degree 3. The degree of this term is 3, the degree of this term is 3, so this is also homogeneous. So what we need to do now, just substitute these transformations, then this dy by dx is y prime, which becomes v plus x dv by dx, and this x remains same, y becomes v cube plus x cube, and this is
x cube vx cube.
v is, y is vx, so this becomes
vx cube
x cube times v, plus this also becomes x cube times v. You just need to take x cube common. This becomes 2x cube v. This one. Is it so?
Yes, sir.
So x cube is cancelled in x cube. You are left with 1 plus v cube divided by 2v. Now you can see the equation is separable. And how to solve separable, we know very well. So now we have left hand side is x dv by dx equals 1 plus v cube divided by 2v minus v. Then this becomes 2v is the LCM, 1 plus v cube minus 2v square. Then this would be
2v dv upon
2v dv upon 1 plus v cube minus 2v square equals dx over
upon x.
Now we need to integrate in this case only. Integration might be difficult, it might be easy depending upon this function that we have so far. So how to do integration?
Partial fraction.
Are we mistaken somewhere? Because this is doing in some other sense. If we are not mistaken, then we are okay, just we need to integrate. So is it okay up to here?
Yes, sir. Okay, sir.
This would be, I think, v square.
B square.
This would be v square, then we are done with it. Okay, so now it will be
V plus v square.
it means we should remove this one only. So x cube v plus
B
v square, and these are cancelled.
Yes, sir.
Now we have x dv by dx equals 1 plus v cube v plus v square minus v. Now LCM would be v plus v square 1 plus v cube, and when these are multiplied minus v minus v cube.
V
Would
cube.
be v cube, I think.
So, yeah.
So this v cube is cancelled in this v cube. Now we are left with 1 minus v divided by v plus
V square minus v cube. V square minus v cube. Third term.
This would be v square.
Yes, sir.
Okay. So now 1 minus b square would be 1 plus b and 1 minus b. Is it so?
Yes.
And v common, we are left with 1 plus.
1 plus v.
This is cancelled.
Yes, sir.
Okay, now we are left with v dv
One.
over 1 minus b equals dx over x.
Yes, sir.
Now you just need to integrate because this is a separable differential equation
Yes, sir.
and integration gives what? Integral v dv
Yes, sir.
over 1 minus v equals integral dx over x.
Yes, sir.
How about this?
18 subtract 1.
Yes.
Then take minus common.
What we can do? We can divide v by 1 minus v. This is easiest way.
Yes, sir. 1 plus
Minus 1 times. And this becomes minus 1 times minus 1 plus v. Minus 1 times plus 1 is minus v. After subtraction we get 1. So minus 1 whole 1 upon 1 minus v. Minus 1 whole 1 upon 1 minus v. So 1 upon 1 minus v and dv integral dx over x. So this is minus v
plus log 1
plus log
1 minus v
1 minus v equals log x,
log x plus c.
and plus you can introduce a constant to be log c.
Yes, sir.
Then how about this one? You can write this one as, I think, log e raised to minus v. Then you can cancel everything. Plus log 1 minus v equals log cx.
cx.
Now you can write log e raised to minus v times 1 minus v,
b
and this is log cx. Logs are cancelled. You are left with e power minus v. 1 minus v equals cx.
cx.
Now you just put v equals back from that one. So what we need to keep in our mind, just what is the general form of a homogeneous differential equation, what is the particular format for that, what substitution do we use, and that substitution leads us to
Separable.
what type of equation. So that is separable equation. So these are some of the bigger things that we need to keep in our mind. So there are some equations which we can reduce into homogeneous form as well. So let us discuss those. So differential equations reducible to homogeneous form. So let me take one form of those equations, and those are dy by dx equals a1x plus b1y plus c1 divided by a2x plus b2y plus c2,
c2.
where we can assume that c1 and c2 are not 0. If they are going to be 0, then this equation becomes homogeneous simply. Because when these are 0, then the degree of this one is 1, 1, 1, 1, then this equation will be homogeneous. But we don't have homogeneous equation here, but we can convert this into homogeneous equation. Okay, so this is the idea. So what transformations do we need to do to convert this one? So the transformations will be your small x, or the x that appears in your equation, and your small y should be equal to some capital X plus some other parameter, let's say h, and this is capital Y plus some other parameter, let's say k. Now when you apply these transformations and you claim that you want this to be homogeneous, you will find some values of h and k that make this equation to be homogeneous. So I think we should understand this idea with the help of an example. And what is the example? The first thing is that there are two cases here. The first case is, case 1 is A1 divided by A2 is not same as B1 divided by B2. It means the ratio of coefficients of X is not same as the ratio of coefficients of Y. Then we will take another case when this ratio is going to be same. A1 divided by A2 is same as B1 divided by B2. So let us understand this idea with the help of an example. So the example that we have so far, maybe we are not going to solve it completely, but we'll just give the bigger picture. So example is dy by dx equals 2y minus x plus 5 or minus x plus 2y plus 5 and 2x plus y, 2x minus y minus 4, 2x minus y minus 4. So I think this is homogeneous, this is equation which is of this form, so we can reduce it into homogeneous equation easily. What you need to do, you need to do this thing only. Substitute small x is equal to capital X plus h, substitute small y is equal to capital Y plus k. Then what happens on the right hand side? I am not going towards the left hand side. Minus x plus h plus 2 times 1 plus 5. So you just substitute x plus h for x and y plus k for small y. This is what we call, you perturb your variable with a small parameter. It means you disturb your parameter with small other parameter. So now what you need to do, you need to separate the variables. The variables are minus x plus 2y, and here the variables are 2x minus y, and you write everything. What is here? Minus h plus 2k plus 5, and this is minus plus 2h, this is 2h minus k minus 4. And if you want this to be homogeneous, you have to make this thing equal to 0 and you have to make this thing equal to 0. So you assume that these are 0 and you just leave out these and you solve your homogeneous equation. This is the first idea. But you have to find out the value of h and k. How do you find out those values? By solving those simultaneous equations. What are the simultaneous equations? Minus h plus 2k plus 5 equals 0. You can solve these two, and 2h minus k minus 4 equals 0. This is system of two equations in two variables. You can easily get the value of h and k. And at the end, you will use these values. What is the problem here so far? Or what is the thing that I have not done so far in this question? Because the idea is simple. You have this equation which is not homogeneous. You can convert this into homogeneous by just applying these type of transformations. When you apply these transformations, you get some extra terms, make those terms equal to 0, find the value of h and k. Okay, let's say you got the value of h to be 1 and k to be 2. You put here 1 and let's say here 2. Then you find the value of capital X and capital Y by taking these values on the left hand side, because you will put the capital X and capital Y value at the end after solving this. Because you want the value in small y and small x, not in capital Y, not in capital X.
Yes, sir.
The problem is my left hand side contains dy by dx, which is what we call the derivative of small y with respect to small x. We have to convert this into capital. Can we do it?
Derivating these both too by taking derivative here.
Taking derivative? How? Derivative of small y with respect to small x is same as the derivative of small y is equal to capital Y plus
K.
plus what? K.
K.
Now I can differentiate this y, capital Y, this would be dy by dx, and derivative of constant is 0. Okay, how to change the small x into capital X? This is very simple again. We know very well, everyone knows chain rule.
dx, yes.
You can convert this into d by capital X
Yes.
and then multiplied by d capital X by d small x. You know very well. D capital X and then derivative of capital X with respect to small x.
Small
We
x.
call this thing to be chain rule.
Chain
You
rule.
evaluate this, you will get the value of dy by dx. Okay, differentiate this thing. This is capital Y. I think.
Yes, sir.
Yes. So d capital Y divided by d capital X.
X.
Then plus derivative of a constant is 0 and derivative of capital X with respect to small x. Derivative of this with respect to derivative of capital X with respect to small x, you take x there and you differentiate, you get 1 as your answer.
Yes,
So
sir.
finally you got d capital Y by d capital X. So these two quantities are equal.
Equal.
And why they are equal? Because capital X is a linear function of capital X and small y is linear function of small y, and their coefficients are 1.
1.
If the coefficient is other than 1, you will get some other answer. So now you can solve it, I think, easily. There will be no any question there. So we have this equation which can be converted into homogeneous, and this is the case 1. What about case 2?
When the coefficients are equal.
When
The ratio.
when the ratios are equal.
This should
Then what happens?
Then I will substitute that is equal to x.
Sir.
अरे मजदूरी हो कैसे तो आखिर में हाणे ता जो साइमल्टेनियस h और k जो वैल्यू मिली होता है
Yes.
वो कांस्टेंट नंबर हो वो सागो फॉर्म थियो ना वरी सेम जी है c1 जे c2 को कांस्टेंट हुआ तो वरी ता वो हल था कि वो टर्मिनोलॉजी तेरी मजदूरी मां जा छा जे लाए या कैसे होमोजेनियस खत्म काथे थी है नहीं होमोजेनियस
Is this homogeneous?
या
No.
This is not
This
homogeneous.
time.
कांस्टेंट भाई
Because of this. After transformations, you assume this is 0
ठीक
and you assume this is 0. So these are removed.
ठीक
Will this be homogeneous?
Yes.
ना ये वैल्यू बड़ी h और k पुरता कदो था
0 थियो ना.
सॉल्यूशन को बाद में होगा.
इहो तव्हां पहिरियां वैल्यू h ऐं k जो कढो,
ठीक
कढी करे पुट कयो, जवाब तो 0 ई ईंदो न.
अच्छा ठीक
तव्हां assume करे छॾियो 0
ठीक
एंड में सॉल्व करे
ठीक।
पुट. So the case is when these ratios are
Equal.
same and we have this to be case 2. Now I am writing my own equation. Let's say dy by dx 2x plus 3y plus 5 and 4x plus 6y plus 9. So this is, you can see that this is not homogeneous,
Yes.
but it can be reduced to homogeneous. And what is the case? These ratios are same.
Equal 1/2.
A1 by A2 you can see 2 by 4
1/2.
is 1/2 and 3 by 6 is 1/2.
1 अच्छे रेशो तलेगी
But these should be same only.
ठीक।
Same. मतलब केड़ो मुझे बस same मुझे. So what can you do here? The simplest thing is you just make these things equal, and these can be made equal easily. You just take 2 common and you get 2x plus 3y plus 9. And you set this whole thing to be equal to some other variable. Let's say z. Then you are done. Then I think we can convert this equation into separable after this transformation. Or it would be separable or homogeneous, let's see. So you can see this term and this term are same. So you can set this term equal to some other variable, let's say it's z. So what can we do now?
To differentiate with respect to that.
Yes, yes. So the problem is when you transform any differential equation into some other variable, or you transform any integration into some other variable, you always need to do everything, that you have to transform everything. So this thing is equal to z, so this will be z and this will be z. The problem is what is the value of dy by dx. So you have to transform everything. So from here you have to find out the value of dy by dx by just differentiating this. With respect to x, you will get
dz by dx.
dz by dx The derivative of x is 1, so this becomes only 2 plus 3 dy by
dx.
dx. From here you can find out the value of dy by dx easily. And I think taking 2 on that side, that becomes dz by dx minus 2, and dividing by 3 we'll get dy by dx. So this is the value of dy by dx. Just put in this equation,
Yes, sir.
this one. So
1 upon
1 upon 3 dz by dx minus 2 equals,
z plus 5.
this is z plus 5
Z plus 5.
and this is
2z plus 9.
2z plus 9. I think this will be a separable equation. First thing is you multiply 3 on this side.
Yes, sir.
So 3 multiplied here would be 3z plus 15 and 2z plus 9, and this is minus 2, it becomes
Plus 2.
plus 2. Then you get dz by dx is 2z plus 9 LCM, 3z plus 5, 4z plus 18. So 4z, 3z, 7z, 18 plus 5, 23, and 2z plus 9, and dz by dx. This is separable, so it can be solved easily
Yes, sir.
by just separating the variables and integrating. So this is another case when we have these ratios to be same. So these are two other equations. 15, yes. This is 15, this would be 15. So 15 plus 18,
33.
33. So this would be
33.